Okay, so you will have the midterm next week. I just want to encourage you with the midterm that it's not that big of a part of your grade, that most of your grade comes about from the work that you do in the lab. So if you look at the syllabus, you see that the midterm is only worth about, is for 65 points out of a total of 550. So it's just a little more than 10% of your grade. So take it seriously and prepare for it, but don't stress over the midterm or the final for that case. If you want to know more about the midterm, look at the website. There is a midterm guide on that website, and it describes to you what the midterm will have on it. And then also there are some past exams. So you can look at these past exams to see the types of questions that you'll expect. But let me explain what you'll see for each one. First of all, you will have multiple choice questions. You'll have 5 multiple choice questions, uh, one or more from the quizzes that you took. So you have 5 multiple choice questions. I will post the quizzes on the Canvas page so you can see, so you can review those quizzes. It'll just be those questions. I'm not going to change them. I'll just pick out 5 questions from those. And then I'll go through and I'll have sections from each of these parts of the study guide. So let's see, let's put this off to the side. There we go. So with the measurements, you're going to have to calculate the average of the set of numbers, calculate the standard error of a set of numbers. So be able to do that. I will provide all equations. I know y'all know how to find the average. You might not know the equation for standard error, but I will provide you that equation, and I'll give you a set of numbers, and you have to calculate the average and the standard error. Of course, in that process, you'll also have to calculate the deviation. Be able to read a ruler and a vernier caliper. Now, for the caliper, there might be a question that is on the free response part of the exam or on the multiple choice part. We had questions on both, but also we will have a practical. So there will be a practical that will involve reading the vernier caliper. I'll give you some object and ask you to measure the dimensions or one or more dimensions on that object. So know how to use the caliper, and then also know the rules for significant figures. I'll probably give you some operation that you have to do and find the appropriate significant figures like we did in Physics 101. The second part is about graphing, and that's really important. I need you to know how to read a graph and how to interpret that graph. So let's just spend just a moment on that. If you recall, we had an example that we did in class where we said that t was equal to 2 pi square root of L over G, and then I rewrote that just to make it look a little more obvious what's the independent and dependent variables. And so I have this function. So you'd have some similar function. It's not going to be this one, but it'll be something similar where I have the dependent and the independent variables here, t and L. This is the dependent variable. This is the independent variable. Of course, the length of the pendulum doesn't depend upon the period. It's the opposite of that. And then I would give you data for t and L, just like we did in lab, and I'll ask you to graph it. And in this particular case, I'd ask you to graph it and tell me what is G. Now, if this was the function and that was the data, what you would do first is you would find the square root of L, and then you would plot T versus square root of L, and you would make it so that the graph covers the entire page, 2/3 or more of the page. Please label these clearly with the units also. I'll be looking for that the labels are clear, the units are clear, that you have the data that has dots with these circles around them so I know what is a data point. And then you draw a best fit line. I'll ask that you know how to draw a best fit line where you use a ruler and you have equal number of points above and below the line. And then you pick 2 points that are not data points and find the slope. And once you find the slope, let's say, for example, the slope here is, I don't know, 2. Let's say that it's 2. Then I would set that slope, which in this case was 2, equal to the coefficient of the independent variable. Remember, the equation of a line is y equals mx plus b. Here, b is equal to 0, and this is the slope. That is the coefficient of the independent variable. So I'd say 2 is equal to 2 pi over root g. And then I would solve that for g, which in this case is equal to pi squared, which turns out to be 9.8 meters per second squared. Your problem will be very similar to that, but it'll be different numbers, and it'll be a different function, and a different type of graph that you'll do. So you're not going to be doing t versus root L. You might be doing, I don't know, x versus t squared, or you might be doing s versus r cubed, or you might be doing L versus m to the half. I don't, it'd be something different, but similar in that way. This is going to be a big part of your exam. More than a third of your exam will come about from graphing these data. So please spend time. If you spend time studying anything, I ask that you spend time studying that. Next, we see that you'll have to be able to interpret, describe, and sketch velocity and displacement versus time graphs. So just remember with those, we did this in the video lab where we were throwing the basketball. If I have a basketball that drops like that, the y versus t graph looks like this. The vy versus t looks like this. Notice here I start out with a small negative slope and it speeds up to a big negative slope, small negative velocity, big negative velocity. That was for the drop. Next, we had the pass, where we had a ball that went between two people. And in this case, we drew several graphs. We drew the y versus t. Y versus t started out like this, looked like this, and then went like that. And then vy versus t looked like this. It started out with a big positive velocity, big positive slope. At the top, the velocity in the y direction is 0, so the slope here is 0, and then it increases in the negative direction. And then also, since this is two-dimensional motion, we have x versus t. Now, since the x velocity is constant, the slope of that line is constant. And then vx versus t, since the velocity is constant, the slope of that line is equal to 0. So, for example, I should know that the slope of this line is equal to the velocity, the slope of this line, and this one too, is equal to the acceleration, and be able to calculate that slope and show that it's the velocity. The third one that we had was the bounce pass. Remember, the bounce pass was a little more difficult, where I had it look like this. My y versus t looked a lot like the motion, looked like that. The vy versus t, let's see, how did that look? It started out with a small negative velocity. Yeah, so it looks like this, and then it goes like that. This is the bounce right here, where I go from having a big negative velocity to a big positive velocity. And then x versus t is the same because my x motion is constant. Actually, at the bounce, if you recall, we had the graph actually smoothed out in that way, or the slope, my eraser, the slope actually decreased because it slowed down after it bounced. And then Vx versus t looked like this, started out with big velocity in the x direction and then smaller velocity in the x direction. So know how to read, interpret, and even go back and forth between those different graphs. That is, if I give you an x versus t, you can draw the v versus t graph. We did that in physics, in the Physics 101 exam. Let's see, next you're going to have to do vector addition and subtraction. That is, I'll give you vectors that you have to add graphically. So if I give you two vectors a plus b, a and b, you have to be able to add them graphically, a plus b. I might give this to you with a scale like we did in lab, where you have to draw them and use the protractor and actually figure out what is the magnitude of this vector. And then I'll give you other vectors, like so a is 2 meters at 30 degrees, and the vector b is equal to 3 meters in the negative y direction, and ask you to tell me what is the magnitude and direction of a plus b, or a minus b, or whatever it may be. Okay, so you'll have to be able to add vectors numerically. Next, after vectors, what do we have? Oh yeah, projectile motion. Be able to describe, graph, or sketch the velocity of an object that's in projectile motion. So for example here, I've already seen this, but if I have an object in projectile motion, this is a lot like the video lab that we did. The y versus t looks like this. The vy versus t looks like that. And the x versus t looks like that. So those are for that. If I have a situation like we did in lab where it's coming off of a horizontal table like that, it's a lot the same, except my y versus t now is just half of that, and my vy versus t is just it's like that, and then my vx versus t is going to be constant. Likewise, it'll be over here, Vx versus T is constant. So be able to know what those graphs are, but if you got the graphs in the video lab, then you should be just fine with this. However, you also will have to, what does it say, be able to calculate the horizontal and vertical range, and then be able to calculate the velocity, initial angle, and travel time of a projectile. So that is, we've been doing this actually quite a bit in class, and we did it in lab as well, that if I give you an object with an initial velocity, say 20 meters per second at 30 degrees, be able to tell me what is the maximum range, what is x equal to, and then what is y equal to. In the course of that, you'll need to know what is this time. You'll need to know what is this time. Um, Likewise, be able to do it for this one, where an object goes off the horizontal, uh, being able to determine what is the x value and what is the velocity at the end and what is the total time that it has in the air. Okay, I would give you, by the way, I would give you the y displacement. That's what you use to find the time. All right, so be able to calculate those, be able to work through those problems. That'll really help you for the upcoming quiz and exam that we're having. I think that's it. You will not have to use the quadratic equation. I will not give you any questions that need use of the quadratic equation, and I will provide any and all equations to you. In fact, if you get on the exam and you think there's an equation that you need, and you don't have it, just ask me, and if I'll either tell you like, no, you don't need that, or I'll give it to the whole class on the board. So yeah, that's it. Again, prepare for it. Actually, any preparation that you do will help you in the class as well, but don't stress over it too much because it's really not that big of a part of your grade.